Alright, today's problem's name is insert, delete and get random in O of 1. So we need to design a data structure that supports all of the following operations and average O of 1 time. So the average time complexity of the data structure that we are going to define must be constant. Okay, so the three functions that we have to complete are this: insert an item value or val to the set if it is not already present. So if it is not present in our data structure, then we need to add it and return true. And remove, we need to remove the element if it is there in the set. Okay, and get random, we need to return a random element from our stored current set of elements. Okay, and the thing is, each element must have the same probability of being returned. It basically just tells us to generate a random number and return it. Alright, okay, so the thing with this problem is the constraint on the time complexity part. So as soon as we hear this constant time complexity, the data structure that comes in our mind is hash set. Okay, so most of the operations of hash set are done in O of 1. You can see that the hash set is implemented using a hash table and elements are not ordered. The add, remove and contains method has constant time complexity. So we can use hash set, and with hash set we need something when we will return in this function get random. Okay, because you can't randomly access any element from hash set, so we need a list too. Okay, so the three things that I need are hash set that will be of integer type, let's call it set, and a list that will also be of integer type, let's call it list, and of course the random function, we need to return a random element, so an object of random class. Okay, so inside this constructor I'll be initializing it. So right, similarly we will go for list, new array list, and for the random object also. Alright, so we need to complete this insert function now. So first of all we will check if suppose set contains this val. So if the set does not contain it, so we will have to add it in both in the set and as well as in the list. So simply add it. This will be in constant time, of course, and list.add val, and we gotta return true if it is already not present, else we will simply return false. Okay, so insert function is done. After that, remove. So here also we need to first check if set dot contains this value. So we can only delete or remove something from our data structure if it is already stored. So that is why this checking is necessary. Then set dot remove, we have to remove it from both set and as well as from the list. So set dot remove this element and list dot remove. In list we have to pass the index basically, not the element, so we will be using here this integer dot value at this. So this is just the syntax how remove or deletion from list take place, and after that return true. Okay, and if it is not already there in our data structure, then you can't remove it, so you have to return false. This function is also done. So now random. Okay, so for this you can simply return from the list.get and the object of random, and from what all values this random function can generate values from what all values, that is set.size. Okay, so it can return any value and this is not biased, so it should work. Here looks good as HashSet and list. I have used both of them because most of the functions of both of these data structure are in constant time. So let's run this code. Charging finished. Okay, accepted. Basic test cases. Let's submit it. Okay, accepted. Okay, so this was the problem, and one thing I would like to say for such problems, that in such problems there are always a hope of improvement or optimization of the code. So a little bit optimization you can always do better than this. I just used the method that was more intuitive, because whenever we talk about constant time, the first thing that comes into the mind is HashSet, and it's a famous problem actually. One of my friends got this question in his Amazon coding interview round, and it was exactly the same problem that I remember. So yeah, it's a good problem, you can look at it, and I'll see you in the next video.